Imagine you live in a rural area. Maybe it's a ranch in Montana or a remote island in the Philippines. You are surrounded by nature, but you are digitally invisible. Today, we live in a world where we have been conditioned to think that the internet is everywhere. We check our phones in subways and stream 4K video in skyscrapers, assuming the connection is just in the air. But the truth is, the internet is surprisingly physical. If you are watching this in London, New York, or Hong Kong, your data is likely traveling through a tube on the bottom of the ocean. These are submarine cables. Inside these cables, we take our entire digital lives and turn them into pulses of visible light. Every 1 and 0 travels through fiber optics at nearly the speed of light. It's an incredible system, but it has a major flaw. It's tied to the ground. If you live in a remote village or a place where laying thousands of miles of glass fibers just isn't profitable for big corporations, you are essentially cut off. You are in a digital dead zone. Now, putting the internet in space isn't exactly a new idea. We've been doing it since 1962. The way it works is pretty straightforward. Instead of using light through a cable, we use radio wave. We take those same 1s and 0s and changing the frequency and amplitude of the wave to carry the data. For decades, the standard was to put a few massive satellites really high up, about 35,000 kilometers. This is called geostationary orbit. It's great because this system places satellites high in the orbit and keep them stationary over one specific spot on the Earth's surface. But it's terrible for your connection. Think about the distance. The signal has to go up and back twice. That's 70,000 kilometers. By the time the data reaches you, there is a massive lag. It's okay for TV broadcasts, but for the modern internet, it's painfully slow. So that's the gap Starlink wanted to fill, connecting the people that the cable forgot without the lag of the old satellites. But how did they fix it? The answer is by moving the satellites closer. Starlink's satellites aren't 35,000 kilometers away. They are much closer to Earth, only at about 550 kilometers away. Because they are so low from Earth, the lag basically disappears. But here's the catch. When you are at that low, you are moving fast. The satellite can't just stay over one spot. A single Starlink satellite zooms across your horizon in just a few minutes. To make this work, Starlink uses a constellation of thousands of satellites, constantly handing your connection off to the next one like a global relay race. And they are getting smarter. The newer ones use space laser to talk to each other in the vacuum of space. This means they can route your data across the planet without ever needing to touch a ground station. On your roof, you've got this flat dish. It looks like a simple flat piece of plastic, but inside is a technical masterpiece, a phased array antenna. Unlike old satellite dishes, this hardware doesn't physically move a single inch. Instead, it uses electricity to do the work. By firing these hundreds of tiny elements at slightly different times, or phases, it creates a focused spin of radio waves. It allows the dish to instantly track a satellite screaming across the sky at 27,000 kilometers per hour. It can switch its focus in a fraction of a millisecond, ensuring your connection never drops. But it also creates a massive geopolitical problem. This is where the story gets complicated. When the war in Ukraine broke out, the first thing to go was the traditional internet. Russian strikes systematically targeted cell towers and fiber optic hubs, effectively blinding the nation. Then the dishes arrived.
Elon Musk is sending another round of Starlink satellite internet terminals to Ukraine.
Initially, they were just a way to help people stay connected. But very quickly, they became the most important part of the Ukrainian military. This wasn't just about checking the news anymore. It was about guiding civilian drones and coordinating precision artillery strikes. Starlink had become the literal backbone of the Ukrainian resistance. But as the fighting intensified, the world realized something deeply unsettling. The switch for this entire military infrastructure didn't belong to a government or an elected leader. It belonged to a private company, and especially to one man, Elon Musk. At first, Elon Musk was seen as a hero. He sent Starlink terminals to Ukraine and got great publicity for helping a country in need. But by the end of 2022, the story became much more complicated. As the fighting continued, SpaceX became worried about how their technology was being used. To control this, they started using geofencing, an attempt to prevent Starlink technology from being used as a weapon. For example, they denied to extend Starlink's coverage to Russian-occupied territory for a counterattack in Crimea. This created a massive debate. It showed that a private company can now have the power to stop a military operation. Suddenly, the world realized that the on and off switch for a nation's defense was in the hand of one billionaire. So here we are. Starlink has achieved something incredible. It's brought high-speed light to places that have been in the dark for decades. It's a lifeline for soldiers and rural families alike. But it's also a warning. For the first time in history, a global essential infrastructure, one that nations now depend on for their survival, isn't managed by a government or a treaty. It is managed by a businessman. Next time you look up, those aren't just stars. They are a new kind of power. And for better or worse, we are all connected to it. Thank you for watching.